So here I have a difference in paired means. And again, what that means is we have two sets of data, but they're really, every row is about the same individual. Okay? So what happened in this case is we asked people, what is your height? And then we actually measured them to compare to see how close they were to their height. And sometimes people overestimated, sometimes people underestimated. So here I'm only displaying the difference, not their self-reported height or their clinically recorded height. I'm just presenting the difference. And if we did have both data sets, we would just subtract them when they're paired like this. So this is a different procedure than when they're independent. And basically this procedure is just like the regular hypothesis test we were doing before. We could copy this data into StatKey to do it too. I'm going to use the spreadsheet to do it. So here's all of the data. I'm just going to copy and paste it into a spreadsheet. This is important because if people self-report, say their height and their weight, and then use that to calculate the BMI, they're probably going to say they're taller than they are and they weigh less than they do, which means they're going to have a lower BMI than is real. And so self-reported data will lead to different BMI, a lower BMI on average than clinically recorded data. That's why your doctor, if you go visit, they get your height, they get your weight, rather than asking you, hey, how much do you weigh today? All right, so then we have to decide on our hypothesis, our sample statistic, our p-value, and then we get to decide on our decision and our conclusion. There we go. So I want to highlight this data. I want to get it into my spreadsheet. I guess I can grab the title too, and I'll share the spreadsheet out with you. Yeah, BMI isn't a great estimate. It's very simplistic. Did I actually copy that? All right, focus Gary. Copy. Spreadsheets. Let's see, do I have a place for this? Now again, paired data is really just like using a single population. So if I go over and find one of my spreadsheets that has a regular mean hypothesis test, like one with data, let's say I have one with data somewhere. Where are you? There we go. We can reclaim this one right here. So I'm going to make a copy of this, duplicate it. And this one is diff HT. Give me a second to paste the data in. Delete. Then paste. There it is. All right. So I'm going to share this. Find this in YouTube in the description also. And let's see. Sorry, Alejandro, I missed your text. What problem did you want to see? The one
it was the one that we just did right now. I just wanted to take a screenshot.
Okay, let me bring it up. This one right here.
No, the previous one. It was the one with the smiling.
Okay, previous one, smiling. This right here. This is the hypothesis test for smiling versus neutral.
Yeah. Mm-hmm.
Okay. You got it?
Thanks.
Yeah. All right. So let's see. I need a new page. All right. In the spreadsheet, so we have the data in there. And this spreadsheet was set up so that if we put any new data in column A, then it would just calculate stuff for us here. Oh, I'm in the confidence interval one. Oops. All right. We'll fix that in a second. So let's see. I guess I need to switch tabs. I think this one was the right one there. Okay, so this one is trash. Wait, no, this one. All right, so I made a mistake here. Let's pull that out. I'm in the wrong sheet. Delete. Yes. Sorry if you were just in that one. We want the hypothesis test, not confidence interval. And then I just want to replace that data. I'm going to have to copy this because I have this linked in the YouTube video. Then I can paste over that column. Okay, now we should be good. Let me just relabel. So this again is heights, diff. So let's see, usually we say there's no difference. Let's see, what did the problem give us for alternative? Let's see, we're testing the claim that a male's self-reported height is different from his actual weight. Okay, so if different, that would be just not equal, two-tailed test. Let's see if there's anything else. Table below gives the differences, self-reported and clinical. And here I have a link to abstract of this study. Test the claim at the 10% significance level. Again, it's self minus clinical first, and then we get the mean after, which we have in the spreadsheet. Okay, so all we have to go on really is the data in this first sentence here, that the self-reported height is different from the actual height. So that means we're doing a two-tail test. So let's copy the two-tail symbol, the not equal to symbol here. Reminder, and then I'm just going to put a little note to myself. Two-tail test. Okay, so it counted 35 numbers here. And that should be accurate. We have a mean difference of 0.692. And what were these measured in? Did it say if it was inches or heights? I think they were in centimeters. Maybe it's in the abstract. Well, I have to go all the way out to there to see it. Okay, I'm just going to assume it's centimeters. But I don't remember to read the report. Back here. All right. Sample standard deviation, got that. And then our alpha, we were given 10%, so I got to change that. So 0.1 is 10%. Standard error is just the standard deviation of the data divided by the square root of the sample size. So I got that in there. T-score, same kind of T-score we usually get. We take our sample statistic, our X bar, we subtract the null value, and then we divide by the standard error. So I got that in there correct. And then I have a whole bunch of p-values to choose from here. I want the two tails. I just want to double check it is correct. And it says take the two-tail T-score and then degrees of freedom. Yep, that looks good. All right, so that is our p-value right there. I want to think about whether this makes sense. So I have a t-score of 0.1259. So remember, a t-score is a count of standard deviations from the mean. So in a picture, let's draw what we get going on to make sure this all makes sense. So we have mean difference in height. Difference, there we go. And that would be mu self minus mu clinical, or did I get the order wrong? Clinical minus self. It is self minus clinical. Okay. Self minus clinical. And our alternative hypothesis is that there is a difference. It's not zero. In the middle, right, there's no difference. So that's this zero up here. It's also like having a t-score of 0. And then 1, 2, 3 standard deviations to the right. We calculated about 1.25-ish standard deviations. So here's 1 standard deviation, there's 2. Our test statistic is about right here. T equals 1.25. Right, that's not way out in the tail. That's kind of close to the middle here. Now, this is a two-tail test, so I have to reflect that over to the other side. T equals negative 1.25. So my p-value is the combination of both of these right here. So that combined with that is my p-value. And it's going to be a pretty big number here. Yeah, so we're saying people, because yeah, so because our sample statistic, that's a good point, sample stat, our X bar difference, which is the average of, no, it's not that. It's first we subtract them, then we take the average. What did we get for that? We get 0.692, that's this number right here, the average difference. It is positive, right? So positive means that in this sample, on average, people said they were taller than they were, but the p-value is pretty big, meaning that, well, it is bigger than 0, but it's really not that much bigger than 0, right? Our p-value is 2.2188. That's a big p-value, right? It is much greater than alpha, even at 10%. Okay, so we're going to fail to reject the null, fail to reject. What we're saying is a difference of positive 0.692, say, centimeters is actually kind of close to 0. But that to say, yeah, that, you know, people are pretty close to their height on average. So we don't have evidence that a person's self-reported height is significantly larger than their clinically recorded height. So what does it mean to fail reject right here? We do not have evidence that a person's self-recorded height self-reported. Oops. Better. Is different. And I got to say different here because that was my alternative. My alternative was not, it's more. I was asked to look at different than their clinically recorded height. For a sample of this size, 0.692 isn't high enough from 0 to say that they're different on average. On average. Will some people report a higher? Yeah, some people will, but not enough. On average. That's important here. I had to have the word average in there somewhere. Okay, so we failed to reject, no big deal. On average, people don't think they're much taller than they are, is what we discovered, at least for men. This was just men.